All right, now we go to question 7. It's question 7, not from the exercise. It is actually from the worked examples. Page 213. In page 213, you have this is worked example number 7. That's what we will be learning. We'll solve this. So, first of all, I'll read the question. The question says, so this is the diagram, and then the question says that in this circle, O is the center of the circle. AB and CD, AB and CD, they are chords of equal length. That's what the question says. And AB is produced further, and CD is also produced further, and then they meet at P, point P. That's what the question says. Now, what we are supposed to prove is PA is equal to PC. This is one thing, and then we need to show that PB is equal to PD. This is the other thing. Now, my construction will be from O, I will draw M, OM perpendicular to AB. So, this is the first part. And then ON perpendicular to CD. I'll do this construction. So, because this perpendicular, I can just show it like this. I can just show this 90 degree on any one side. That's enough. Next, we have AB is equal to CD. How do we know it is given? That these two chords are of equal length. And then because M is the midpoint of AB, AM is equal to MB, and similarly N is the midpoint of CD, CN is equal to ND. Now AB is equal to CD, therefore AM is equal to BM is equal to CN is equal to DN. This is one result. We will need it later. We will keep this as result 1. And then next what I will do is next draw OP or join OP. Let me change this. Instead of draw OP, I'll just write join OP. Join OP. Okay, done. Now I have two triangles. Consider triangle OMP and triangle ONP. When you consider these two triangles, I will use RHS because I can show 90 degree in both of them, and hypotenuse is common to both, and then any one side I can show that OM is equal to ON. So I will use RHS. So first the right angle OMP is equal to angle ONP is equal to 90 degree. This is one thing. And then so we have shown the right angle in both the triangles. Then hypotenuse OP is the hypotenuse, and it is common. OP is common, hypotenuse is shown. Next, OM is equal to ON. Equal chords are equidistant. OM is equal to ON, and I call this as OM is equal to ON. So one side, OM is equal to ON, side is shown. So now I will use RHS congruency. By RHS congruency, I have triangle OMP is congruent to triangle ONP. Okay, this is done. Next, because of this, I can show that this part, MP, this entire thing MP, this and this side are of equal length. I can show that these two are of equal length. So I will write OMP is equal to NP CPCTC. Okay, this is done. So just excuse me for a second. I lock the door. Next, MP is equal to NP. Do I need this result? I think I need this result, and I'll call this equation 2. Okay, equation 2. Now what I will do is okay, instead of equation 2, what I will do here, I will collect AM is equal to CN. AM is equal to CN. So I will call that AM is equal to Cn as equation 1, and then Bm is equal to Dn is equal to Dn. I'll call this equation 2, and this one I'll call it equation 3. Okay. Now what I can do is equation 1 plus equation 3 gives equation 1 plus 3 gives AM plus MP. Left hand sides I am adding, that's all. AM plus MP is equal to right hand side Cn plus Np. Cn plus Np. Now see the diagram, AM plus MP. AM plus MP, which is nothing but AP. AP is equal to CP. I think this is the first result we are supposed to prove. Yeah, AP is equal to CP. Yes, this is the first result that we are supposed to prove. Done. Next, what I will do, equation 3 minus 2 gives 3 minus 2 gives MP left hand side and left hand side of 3 and left hand side of 2. MP minus BM is equal to NP minus DN. So what is MP minus BM? Just see the diagram. MP minus BM gives you BP. It gives you BP is equal to NP minus DN. Let's go to the M, gives you DP. So this is the second result that we are supposed to prove. First result is this and second result is this one. BP is equal to DP or PB is equal to DPD. Done. So this is how you solve this question 7. And then from the exercise, which is exercise 17B, we move to exercise 17B problem 6. We'll solve problem 6. Where is it? 17B, sixth one. All right. So he's given a diagram. I'll copy the diagram. Okay. There's a circle. Okay. And then there's a square. Okay, circle and a square. This is what is given. And then it is named as O Q A B C, and this is P. Okay, done. So let's read the question first. In the following figure, OABC is a square. So this is a square, and a circle is drawn with O as the center, which meets OC at P and then OA at Q. Okay, fine. I need to prove that OPA, triangle OPA is congruent to triangle OQC, and then triangle BPC is congruent to triangle BQA. These are the two things that I'm supposed to prove. Okay. First OPA. Where is it? It is this one. This is OPA and then OQC. Okay. OPA and then OQC. How do I show this? Let me use a different color. Maybe what color can I use? Yeah. This and let the other one be entirely in orange, I guess. Yeah. Okay. These two triangles are congruent. That's what I'm supposed to prove. How can I prove that? Has he given any other measurements or something like that here? No, not at all. But still, we can prove this, is what I feel. Consider triangle OPA and triangle OQC. Consider these two triangles. OP is equal to OQ, I can say that. OP is equal to OQ. Why? Because they are the radius of the circle. I'll just write as radii. Okay, this is done. Next, OC, OPA, OPA, OA is equal to OC. Reason is, sides of the square. And then OPOA, and then I can show that because it is a square, this will be 90 degrees. So I can write, so OPA, POA, POA is equal to COQ or QOC. I will write it as QOC equals 90 degree. It's given, it's a square. So two sides OPOA and the angle between these two sides is 90 degree. So by SAS, I have triangle OPA is OPA. Wait, let me erase and write it properly. OPA is congruent to triangle OQC. Done. So OPA is congruent to triangle OQC. Exactly like that, you should be able to prove the other part also, I guess. Then what is the other part? BPC. Let me use this. BPC. Okay. BPC and then BQA. BPC and BQA. I need to show that these two triangles are also congruent. How can I prove that? I will, okay, again just write, consider these two triangles. Consider triangle BPC and triangle BQA. BQA. I need this diagram. What I'll do is I will minimize this a little bit. I'll bring this thing here and let me replace this here. Okay, okay, done. Now let us come to this. Consider triangle BPC and BQA. If you consider these two triangles, I can say that BC and then BA are equal. I can show that. After that, what else can I do? 1 second. Question 6. BC is equal to BA sides of the square, that I can do. Angle 90 degree I can show, and then CP is equal to AQ. How can I show that? AQ. Yes, got it. Yes, here what I will do is, when I consider these two triangles, in triangle BPC, which is this one, so I'm comparing this triangle and then this triangle. In triangle BPC, sorry, mistake. So in triangle BPC, BC is equal to BA. Why? They are the sides of the square or square. They will be equal. This is done. Next, what I can do is I can show that this angle is equal to this angle because they are angles of a square. Angle BCP is equal to angle BAQ equals 90 degree. This is done. Next, I have to show that this side CP is equal to QA. This is all I have to do. What I will do is CP is equal to OC minus OP, and I have CP and then QA. QA is equal to OA minus OQ. Okay. CP is equal to OC minus, okay, yeah, I can do this. QA is equal to OA is equal to OC, sides of the square, minus OQ is equal to OP, because OA is equal to OC and OQ is equal to OP, because OQ and OP, they are the radii of the circle. They are the radii of the circle. So I'll call this equation 1 and I'll call this equation 2. From 1 and 2 I have CP is equal to QA. So now therefore, because of this, and this, these three things, I can use by SAS. I have triangle BPC is congruent to triangle BQA. That's it. So this finishes your chapter. This finishes exercise 17B. These are the problems I'll be solving from exercise 17B. Then we are moving to exercise 17C. We'll be solving problem 1, problem 5, problem 6 and then 8. These are the problems we are solving from 17C, which we'll learn in tomorrow's class. So that's it. Bye.